Video, we're going to take a look at question 2 of Cape 2025 Pure Maths Unit 2. The first part reads, let f equal sine of 3x squared y to the 4 show that the partial derivative with respect to x of f, so df dx is 6xy to the 4 times cosine 3x squared y to the 4. So to give you the answer, that helps a lot to make sure that you didn't make any mistakes after you reach your final answer. Just double check and see that you get exactly what they said. Okay, now to remind you, when you have to find the partial derivative with respect to x, one thing you have to do is you have to make sure, basically, you're just treating y as a constant and then you're just doing normal differentiation. So if f is equal to sine of 3x squared y to the 4, then df dx, well, the first thing is I have to differentiate sine. I'm using the chain rule. So when I differentiate sine, I get cosine 3x squared y to the 4, and I have to multiply by the derivative of the inside. So that's multiply, and now it's just x squared. When you differentiate x squared, you get 2x, but 2 times 3 is 6, so it'll be 6x y to the 4. And then you could just rearrange, so you get 6x y to the 4 cosine 3x squared y to the 4, which is exactly what they had, so we did this correctly. Okay. Part B now is, given that d dy is this, find d2 on dy of sine 3x squared y to the 4. Now, if you have to find the partial derivative with respect to x and then y, you could do it two ways. One, you could differentiate with respect to x first, and then you could differentiate with respect to y. Or you could do it the other way around and differentiate with respect to y first, and then differentiate with respect to x. So what you could do is you could take this here and differentiate it with respect to x, this thing. But what I'm going to do is I'm just going to use the form that we found, which is that, and differentiate with respect to y. So d2 on dx dy of sine 3x squared y to the 4. What I'm going to say is it's equal to this derivative with respect to y of 6x y to the 4 cosine of 3x squared y to the 4. Now, when I'm differentiating with respect to y now, x is the constant, and you see that there are two terms with y, so you have to use the product rule. So the first one is 6x and then times 4y cubed, and then keep the cosine as it is, and then plus 6xy to the 4. Well, actually, it'll be minus, because when you differentiate cosine, you get minus sign. So minus 6xy to the 4 sine 3x squared y to the 4, and then multiplied by, when you differentiate this inside, it'll be 4y cubed, and then 4 times 3 will be 12x squared y cubed. So then I could just simplify all of this. 6 times 4 is 24, and then xy cubed cosine 3x squared y to the 4, and then here 6 times 12 is 72, so minus 72. X times x squared is x cubed, and then 4 times y3 is y to the 7. Sine of 3x squared y to the 4. It'd be a little nice if they told you what the final answer should be for this one rather than party, but I mean, they didn't, so this is just, you just have to make sure you don't make any algebra mistakes. Okay. That's that. Okay. Let's now do the partial fractions question. So it says, use partial fractions to show that x squared plus 7 over x squared plus 3x plus 2 is equal to 1 plus 8 over x plus 1 minus 11 over x plus 2. Now, the first thing is it's a little tricky, that in the sense that when you learn partial fractions in class, a lot of the times you're going to be practicing on what's called proper fractions. Proper fractions are when the numerator has a degree less than the denominator, and that's when partial fractions, the usual method, always works. But here you see that both of them have degree 2. There's an x squared term on the numerator and an x squared term on the denominator, so they're the same. If you try to use the traditional partial fractions, it actually wouldn't work here. You have to do a little manipulation first. Let me just show you the manipulation, and then we're going to use partial fractions. And I mean, you could get a little hint that you have to use proper fractions when they put this, when they put the little 1 there, right here. That's a little hint that you see that there's something that's not like in our usual partial fractions, there's not a 1 just hanging around. So that's a hint. When you see like a number in the answer that's not a fraction, that's a hint that you have to use some kind of you have to use some manipulation first. So let me show you how you do it. Let's start with the original fraction, x squared plus 7 over x squared plus 3x plus 2. And I want to remove the x squared from the numerator. So what I'm going to do is I'm going to add and subtract this. X squared plus 3x plus 2, and then plus 7, and then minus 3x minus 2, all over x squared plus 3x plus 2. And now I'm going to split up the fraction, so it'll be x squared plus 3x plus 2 over x squared plus 3x plus 2. And then plus 7 minus 2 is 5, so 5 minus 3x over x squared plus 3x plus 2. And this part here is just 1. The numerator and denominator are the same. So just 1 plus 5 minus 3x over x squared plus 3x plus 2. And that 1 matches up with the 1 that they have in the final answer. So, that gives you some confidence that we started correctly. So now let's do partial fractions on this thing here, this 5 minus 3x. First thing is we have to factorize x squared plus 3x plus 2. If you factorize it, you want numbers that add up to 3 and multiply to give 2. So that's 2 and 1. So what you'll do is, okay, it's x squared plus x plus 2x plus 2. That's x times x plus 1 plus 2 times x plus 1. So that's just x plus 2 times x plus 1. So now let's say 5 minus 3x over x squared plus 3x plus 2. Let's say it's a over x plus 2 plus b over x plus 1. Now there are two ways that you could solve this from this position. One thing you could do is you could actually just substitute particular values of x and figure out the answer. Or, let me show you another way. What happens if I multiply by x plus 2 times x plus 1? Remember, x plus 2 times x plus 1 is this denominator. So if I multiply, what I'll get is 5 minus 3x is equal to a times x plus 1, because the x plus 2 will cancel with this denominator x plus 2, and then similarly plus b times x plus 2. Now I can expand this as a plus b times x, and then plus a plus 2b. And what I could do is I could compare coefficients, and I could say, oh, okay, well here the coefficient of x is minus 3, and here it's a plus b. So a plus b should be equal to minus 3. And then similarly, the constant coefficient is 5, and it's a plus 2b. So a plus 2b is 5. And then if I subtract, either solve these simultaneously. So let's say this is 1, let's say this is 2. 2 minus 1 is going to be b is equal to 8. And then in 1, a must equal to minus 11, right? And then therefore, thus, kind of running out of space, but 5 minus 3x over x squared plus 3x plus 2 equals minus 11 over x plus 2 plus 8 over x plus 1. So now if I put it back into my original thing here, right, what I'll get is x squared plus 7 over x squared plus 3x plus 2 equals, so where I'm just going to use this same expression right here, but instead of the 5 minus 3x over x squared plus 3x plus 2, I use this, right? So it's just going to be 1 plus 8 over x plus 1 minus 11 over x plus 2. And to see if we did it correctly, let's see if they have the same thing, and they do. So, yeah, we did it right. If you see you have a 7 instead of a 8, something went wrong. One thing you could do, like, to kind of cheat for the answer is, like, when you have it in this form, right, you should realize that, oh, from the final answer, b has to be 8, because, it's 8 over x plus 1, and a has to be minus 11. So, when you're solving the simultaneous equation, if again b is something else, that immediately should stop you and be like, oh, wait, something is a bit off here, right? Okay, cool. So, when they give you the final answer, it's not just, like, yes, it is true, like, the main thing you'll be using it for is to just make sure at the end, you check over your work, but you could use it to help you throughout the steps. Because, like, for example, we use it in 3 ways here, right? We use it first to realize we had to use some algebraic fraction manipulation to begin because of this 1. Then we could use it when solving the simultaneous equations to figure out what b and a are, and then we could use it to check the final answer at the end. So, try and use these pieces of information to help you, because, like, if you make a mistake, let me say I make a mistake on line 3 here, right? In terms of time, if I want to come back and fix that, everything that I did after that is incorrect. It's a waste of time. in a sense. It's not really, it's not 100% a waste of time in the sense that, like, if I have to change that 3 to a 5, I just go line by line and change the 3 to a 5. But it is still true that the earlier you catch the mistake is the better. So it helps to just keep it in mind. Obviously, I'm not saying to, like, if it is difficult, don't worry, just use it to just do what you know what to do, and then check it back at the end to make sure everything is correct. But it will help if, like, you just keep in mind what certain things should end up looking like if they give you the final answer, right? It's just a useful piece of information, and using the information can help you save time in certain cases. One of the things, though, is sometimes they do give you incorrect pieces of information or, like, wrong stuff. They do make errors sometimes, but again, I think the main thing is just to know how to do the procedure. That's what going to get the points in the in K. So even if something is slightly off, if you start with what they said that was incorrect and do the right steps after that, you're gonna get full points because that's what they're really testing you on. So I wouldn't worry too much even if they have an error in the paper. Okay. Hence or otherwise, integrate this thing. So what we'll say is, okay, integral x squared plus 7 over x squared plus 3x plus 2 dx is equal, if I use the partial fractions, it's 1 plus 8 over x plus 1, I think, and then minus 11 over x plus 2 dx. Let me just double check that's what it is. Yep. And you just have to remember that the integral of 1 is x, and then the integral of 1 over x is ln x, and then similarly the integral of 1 of x plus 1 will be ln x plus 1, and so on. So plus 8 ln x plus 1 minus 11 ln x plus 2, and then plus c. Just write this a little better. So yeah, this is how you use partial fractions to integrate. I mean, that's one of the main uses of partial fractions, is to help with integration. Okay. And then the last part of question 2 is to use this substitution to find this integral. So let's start. Let's say x was 4 sine theta. Then dx d theta, if I differentiate with respect to theta, it's just 4 cosine theta. So then dx is equal to 4 cosine theta d theta. And then the other thing, okay, well, let's just put all that in now. So the integral x over 16 minus x squared. 16, let me start a little more to the left. Integral of x over 16 minus x squared dx. So x is 4 sine theta, right? So it's integral of 4 sine theta over 16, and then x squared will be 16 minus 16 sine squared theta. And then dx is times 4 cosine theta d theta. And now I could cancel the 16s on top and bottom. So I'll get integral sine theta cosine theta over 1 minus sine squared theta d theta. But 1 minus sine squared theta is cosine theta. Cosine squared theta, so it's integral sine theta cosine theta over cos squared theta d theta. And then I could cancel one of the coses, so it'll be integral sine theta over cosine theta d theta, which is the integral of tan. And if you know what the integral of tan is, you could go ahead and just do that. But I just forgot the integral of tan, so let me just show you how you would do it too. From here, what I'd say is I'd say v equal cosine theta. So then dv is equal to minus sine theta d theta. So then if I do that, it will be integral, now numerator is sine theta d theta. So that'll just be minus dv over v, which is then minus ln of v plus a constant. The last thing is you have to change back v into x. So we'll do that one at a time. So it's minus ln of cosine theta plus c. But what is cosine theta? Well, you have to write cosine theta in terms of x. The way I would do it is this, right? We know that cosine theta, well, the way you do it, I think, is cosine theta will be the square root of 1 minus sine squared theta. And then sine theta is x over 4. So it'll be square root 1 minus x squared over 16. So if I put all that in, it'll be minus ln square root of 1 minus x squared over 16 plus c.